Okay, so now we're going to talk about the authoring library and what it is, what it contains, and how to use it. So the first thing we need to understand before we start authoring our own data, aside from what we've already talked about, why we'd want to do it, we want to understand a little bit more about what exactly is StreamCache and what different flavors does it come in and what does it contain. So a StreamCache is simply a container, and there's a number of things that we can put in this container. Now, the idea behind the StreamCache is it is a file format designed for viewing. So the things that we support putting in the StreamCache are mostly concerned with how we're going to display this data on the screen. Now, we also put in some metadata around that, but primarily we want to put in data that we're going to display, and we want to store it and structure it in a way that makes it easy to stream from the server to the client. So we support a number of things that we can put in here. So obviously the first big one is geometry and tessellation. So this is the triangles that we're going to actually stream down and render on the client. We also support graphics attributes, so materials, textures, matrices, and states. So again, these are stored internally in a way that makes it easy to get to the client. So it may be stored slightly different than other systems, but know that the reason for this is that we want to be able to really efficiently get that down to the client. Now, moving along, we talked about the graphics related things, but now we have some additional data that we can store in there that is more engineered or more relevant to engineering graphics. So we have the assembly tree, and this is, you build this up as you're authoring the data, and you link your geometry to different nodes in the assembly tree. We can also store face and edge measurement data. So this is going to facilitate those measurement operators that we've seen in Hoot's Communicator. We can store PMI information along with views and user attributes. So this allows us to recreate a lot of the standard features that people have come to expect when viewing CAD data, but also we separate these out from the geometry and the tessellation. So remember when we talked about in the previous modules that we would stream sort of the objects that you can see first and the largest one. So that's around these objects, the geometry, tessellation, and then the graphics attributes. But we also stream down these other items sort of interleaved with the graphics so that we make them available as needed. But the primary focus is to get the graphics data down as quickly as possible. Now, with the authoring library, you can edit and modify existing SC models. So you can open them up, you can make slight edits. It's not a full-fledged modeling application or modeling library, but you are able to slightly modify some attributes. You can also combine SC models, so it's almost like an inverse operation of the shattered, if you need to do that for whatever reason. So again, a cache, we have this concept of a model, and a cache is just a database of models. We'll talk about models in a little bit. But essentially what you do is just think of it as a database. And you can open the database, or you can create a new one. You can get the version of the cache. And all caches are backwards compatible with those created using Hoot's Communicator 2017 or later. And that should cover the vast majority of the models in circulation today. So let's talk briefly about what a model is. Okay? So a model is sort of the topmost container in a StreamCache, and it contains all of the 3D and the model structure data that we saw on the previous slide in one data structure. It can also reference other models, right? So that's how we kind of make the shattered work. We make the master model that references the other models. So a model can reference these other models, and there are different variants of how we store these StreamCache files. And we'll talk a little bit about those now. So in its most raw form, the StreamCache is a directory of a couple of different files. Now, we don't need to understand what exactly all those files do, but just know they contain different data types. So for example, in the StreamCache folder, there'll be a file that contains all the mesh data, texture data, metadata, things of that nature. So the advantage of this is that this is the fastest mode in terms of reading the files. There's no overhead of decompressing or of searching. So we know exactly where every file is, and we can just pull the data out as needed. Now, in this mode, we have to manage a directory instead of a single file. So we'll talk a little bit more about that in the server concept of why that could be a pain. But just know that in the default version, you get out a directory, and it has all the different data kind of stored in that directory in a nice way that it can quickly read it and stream it. Now, we realize that storing directories of multiple files can be a pain, so we do have a number of single file options for Communicator. So the first one is called SCZ, and we talked a little bit about this in the past, but SCZ files are essentially that directory zipped up into a single archive. So you only have to worry about this one file. Now, it's not actually using zip, it's using a different compression algorithm, but that algorithm is optimized for decompression. So it takes longer to encode than it does to decode. But the advantage of that is that when you go to open this file, it's very quick to decompress, relatively. You don't want to use SCZ for very large models, because as the model size increases vastly into the hundreds of megs or even into the gigabytes, there is an overhead for decompression. It's not free, and it does take some amount of time to do that. So if you're using really large buildings, cars, airplanes, etc., we do recommend using the non-compressed version. Okay, that's just because you don't want to have that delay of decompression. Now, one thing that we do want to talk about, it is a single file version of the StreamCache, but it's in a different vein, and it does warrant some conversation because it is useful for a lot of people. So this concept of an SCS file, and an SCS file is essentially a captured streaming session encoded into a file. So what does that mean? So what it means is that when we create an SCS file, we essentially record streaming that model in the all mode down to the client. But the client is simply ourselves, and we record all that data as it comes in and write it to an SCS file. And this is useful because it eliminates the need to have that server backend. Okay, this file is just something that you can send down to our client like a normal file from the web, and we can parse that file and display it in the browser. And the nice thing is we do get a little bit of that streaming, that intelligent streaming setup based on the initial camera of this author in that model. So the drawback to the SCS file is that it does require the entire file to be transferred before we can begin streaming. So the reason for this is that SCS files are loaded through like AJAX requests. So that request has to be processed by the browser and the file downloaded before the parsing can begin. However, once the file's been downloaded, you still can interact with the model by rotating it while it's still parsing that file. So the thing has to be downloaded, parsing then begins, and you can still interact with it, but you do have to have that entire file downloaded. So it's a trade-off. For small files, it can be very useful because these files will download very quickly and parsing them will go very quick. But for large models, you can see it being a problem. Like imagine if you had a 300 megabyte model, you have to download that 300 meg file before you can even begin interacting with it. So it's a trade-off between the streaming and the SCS in terms of complexity of the server side versus the time it takes before you can start interacting